So let's say you've been asked to factorize a quadratic. What is it you're trying to do? You're trying to put it into a form which is the same, equivalent, but it has brackets in it. Generally, the bracket form or the factorized form is simplified. It's the most simplified form, especially with algebra, where if we have an algebraic fraction with a quadratic, we want to factorize it, and then that factorized form will allow us to see factors that cancel and simplify. Well, it's how we factorize the number fractions. We find a factor in the top and the bottom. It's a bit easier because it's not algebra. And then we cancel down that factor on the numerator and denominator. So it has its uses, and mainly we'll be using it to go on and then solve it. In other words, find the roots. This is important for the higher paper, GCSE especially, because if there's an equation, it's most likely going to be a quadratic equation to solve. So really good to get fluent on this. And looking at the quadratic here, I can tell it's a quadratic because it has a squared. Okay, so an x squared term. The general form for a quadratic is on the right, ax squared plus bx plus c, where a, b and c are all the different constants, and that could take any well, it could be a fraction, decimal, it could be an integer, and later on any number at all really. So being aware of what each of these could be helps you to define like what to do. So the a in this case is equal to 1. There's only one x squared. This is a very special case of the quadratic, and it's the most simple. This is the a equals 1 form. Okay, so how do we start by doing this? I recommend first to look at the expanding of double brackets. When you look at the expanding of double brackets and you do enough of them, you'll start to notice patterns. Now, to give you an idea of double brackets, we have x plus 5, x plus 2. This is what we mean by double brackets, a quadratic set of brackets. This is an answer to a question up the top here, factorize this quadratic. It's a different question. The idea is that we would be putting this quadratic into this form. It's important to know that for this method, because this particular way of doing it is more of a quick algorithmic process. If you're going to do it using grouping, it's a little bit more intuitive, a little bit more maths involved there, a bit more factorizing, but it's important to know which elements you're after. So what we're actually after when we do this method is the number 5 and 2. Those are the things that will change in all of our answers. Could be positive, negative, or any number under the sum. So what happens when we expand this bracket? Well, if I expand these brackets, I get x squared plus 7x plus 10. Well, it's not ours, obviously, but you can see that it's roughly the same form. And each of the numbers that you might have in these brackets, no matter what they are, will give you a specific output of a quadratic. And we today are going backwards towards these brackets. So when you do the expanding brackets, you'll realize that the two numbers that you have in these brackets will, when multiplied together, give you the plus c. So we give it a multiply there. And then when we add them together, it will give you the b term. So we give it an add there. So how would we sort of generalize this or give it a short form so that we could work with it? Well, we draw a cross. And this cross just allows us to organize our thoughts. The cross will contain the c term and the b term, which are the important terms here, because it's always 1x squared with these simple ones. So we could put, just so you know, we've moved on to the actual question now. 5, and it doesn't matter if it's plus or minus 5 for the c term. We'll figure out whether it's positive or negative when we get to sorting out the b term. The b term goes on the left here. From the expansion of the double brackets, we know that we're looking for factors of 5. And we're looking for those same factors to add up to get to -6. Now I say add up, but that could be subtract as well. It's quite straightforward. When the numbers are prime, we can write down the factors. Now from experience, and when I was young, I would write down 5, 1 as well. So that's 1, 5 and 5, 1. And I was thinking, well, which one would it be? Would it be this way around, that way around? It doesn't really matter. And so 1 and 5 is good. You don't need to repeat with different orders. We only have one set, so we're dealing with the number 1 and 5. We need to think about what we could do with 1 and 5 to get to -6. In terms of addition and subtraction, I would probably want to subtract both of them. There's another way of getting there. I always say I don't think, it's not because I haven't put thought into it, but I certainly have a good inkling that that's the way to do it. So I have -5 and -1, and you can see that if I did -5 and then subtract 1, I would get my -6. So these are the numbers that we need. I didn't think about the order or the positive or negative on the right hand side of this table, and I still have now on the left the correct numbers that I'm after. These are the numbers that go into the brackets. So we know we're looking for something that looks roughly like this. So we open up our brackets, and these numbers here, literally as they are, keeping the sign that you gave them, go inside with the X into the brackets, like so. And this is the factorized form for the quadratic. You can test. It's always good to do that, especially if you're feeling unsure. And we'll expand the brackets. We get x squared minus 6x plus 5, because two negatives multiplied together give you a positive. So that's just a double check to see we've done that. So we factorize it, we put it into brackets. It's ready to perhaps simplify on a fraction. So what we have here are 4 different equations, and we'll do them one at a time. So for question A, we are looking to set up a cross, and we've got a 3 and a -4. Prime number, easy, we've got 1 and 3, and we're going to take away both of those numbers to get to our -4, and so our brackets will have x -3 or x minus 3 and x minus 1. I want to just be careful, because often people put a gap in between. I'm just going to show you and then very quickly erase it, because it will burn a hole in the back of your eyes. You've got the space here. Just try and keep it close. Again, if I was to go on and solve this, I put it equal to 0, but I'm not. On with the show. B, we have x squared minus 5x, so it's the same method here as before. And I'll just show that by writing it right underneath. In this case, we have 2 different options, and we must remember that we do write all of them just in case. Now, I'm just using my head here a bit and thinking 2 and 2, there's no way I'm going to get to 5. Yeah, I can add them together to get 4. I could take them away to get -4. I can add 1, take away 1, I get 0. It's not going to get 5. But the 1 and 4 are the prime candidates there. So I'm going to take away 4 and take away 1, and I will be at -5. So again, another example where we have 2 subtracts. Okay, C, slightly different. We have a negative C term at the end here. So let's see how this pans out, because in this case, we'll see how good it is at automatically helping us. So we have 35, and you'll notice that I only write the magnitude, because I don't need to worry about whether it's positive or negative. It's the left-hand column that does that for me. And we're trying to get to -2. So we think about patterns, pairs of factors. We've got 1 and 35. We go through in order. 2 doesn't work. 3, 4, and 5. Yeah, so we've got 5 and 7. And we start to repeat ourselves. We know we've done them all. So don't forget that basic idea is doing your factors in pairs will help you not miss them, etc. Now, thinking about these two, which one's going to get you to -2? Typically, you're looking for two numbers with a difference of 2. If you like take one from the other, you'll get what you're after. That typically what happens, you look at 1 and 35, you're going to get 36 or 34 if you're going to add and subtract. So how do we then get to -2? Well, I know that -2 is below 0, so we're going to be taking the bigger number away from the smaller number. So the smaller number is going to be the positive. I always write +5, don't just write 5. And then that allows you to see exactly what goes in the brackets. And we're going to take away the bigger number. And you can confirm 5 take away 7 is -2. So we set up our form. And we're going to get x plus 5, x takes 7. Let's factorize. Okay, D is the last one. Just like before, we've got 28 minus 11. Now what's different about this one is you're increasing the number of factors. 3 and 4 doesn't go in. 5, 6, 4 does go in. What are you on about? 4 and 7. 5, 6, and that's it. So now we have 3 factors to choose from. Just want to highlight that if you are after -11, you're looking for two numbers that either the difference between them is 11, or if you add them together is what you're after, 11-ish. It doesn't matter if it's negative or positive if you're adding them together, because you could just as easily take them both. Not going to be the first one. 14 gives you 12 and 16. So if you check the 4 and the 7, you know they add together to get 11. We have to take both of those. So put them in brackets, just as they are.